quadratic equations by factoring. So most of this is going to be kind of review for you. So it says you can find the zeros of quadratic equations by factoring. So in the last section we did a t-table and we found where it was crossing the x-axis. We don't have to do that, we can factor. So to do this we use something called the zero product property. Hopefully you remember this from Algebra 1. So it's when you have something like 2x minus 1 times 3x plus 5 equals 0. And you basically set each piece equal to 0. So you say, oh, well, that means that 2x minus 1 equals 0, or it means that 3x plus 5 is equal to 0. So x could be, right, add 1, divide by 2. X could be 1/2, or x could be subtract 5, divide by 3, 5/3. And both of those would end up working in the original, and then both make it 0. Okay, so that's called the zero product property. So we're going to try to factor, and we're going to have it all set equal to 0 so that we can find what our solutions are. So it says find the zeros of each function by factoring. So I have f of x equals x squared minus 6x plus 8. So I'm going to factor, and I have x minus 4 and x minus 2. And I want to set my function equal to 0. So that means that x minus 4 could equal 0, or x minus 2 could equal 0. So I would get x equals 4. And x equals 2 is my solutions. So relating this to the graphing that we were doing before, it means that we have a parabola that is going through 2 and 4 for the x-intercepts. That's what that's saying. So the next one doesn't have a number right here. So when it doesn't have a number and it's not a trinomial like that, we can just pull out a common factor. So I'm going to pull out an x, and I'm actually going to pull out a negative as well. So negative x. So if I do that, then I would have x minus 4 left. You can always check by multiplying the negative x back in. So you get it set equal to 0. So you have negative x equals 0, and you have x minus 4 equals 0. So divide by negative 1, you still get x equals 0. And this one you get x equals 4. So this means that you would have x-intercepts at 0, 0, and 4, 0. Okay, does that make sense? All right, so in physics, you sometimes talk about projectile motion. So projectile motion is represented by this equation, h of t equals negative 16 t squared plus v sub o t plus h sub 0. Okay, when you have a subscript of 0, it just means initial. So when you see v sub o, it is the initial height, or sorry, initial velocity. And h sub 0 is the initial height. The subscript of 0 just means at time 0. Okay, you don't have to memorize this formula. There's actually a second formula as well if you were in meters and seconds. So I'll always give you this formula if I put it on a test. Okay, so in this first example, it says Rowan hit a golf ball on the ground with her driver. So we have a little Rowan here, golfing. Looks like she's holding a like a club. She's gonna golf. She's gonna hit it, and it's gonna go up and then down, and it's going to land over here. All right, so we want to find the height as a function over time, and the ball was hit with an initial velocity of 100. So that means that v sub 0 is equal to 100. Okay, but in the formula, I have two things that have a subscript of 0. I also have h sub 0. What is h sub 0 in this problem? Where did she hit the ball? 0. It's at a height of 0, right? She hit it on the ground. You said 8.
No, I said 8.
Oh, I thought you said 8. I was like, okay, she's hitting it very high. Just whacking it in the air. As my drawing indicates, right? All right, so anyway, so we have h of t is equal to negative 16 t squared plus v sub 0, so 100t, plus 0. Make the t's little curly t's. It's hard with t's and pluses. So the second question says, well, how long will her ball stay in the air? Okay, so what we're trying to find is when we hit over here. When it hits a height of 0 again. That's what we want. Okay, so I'm finding when my height, h of t, kind of like a function like f of x, then the whole thing is equal to 0. So 0 equals negative 16 t squared plus 100t. So I don't really have a number, so I don't have to do my two sets of parentheses to factor. I just pull out a GCF. So you could just pull out a t, I'm going to pull out a -4, though. -4t. So when I do that, I get 4t minus 25. Is that equal to 0? So this is where the zero product property comes into play. So I say -4t could equal 0, or 4t minus 25 could equal 0. So I get t equals 0, and I get 25 divided by 4, which is 6.25 if you want to see it as a decimal. So 6.25 is my other answer. So the question is, how long will it stay in the air? T equals 0 is representing where it started, right? At time 0, it was on the ground. 6.25 is representing when it landed again. So it's 6.25 seconds is how long it will be in the air. Usually that makes sense, right? It's clearly in seconds. It was not 6.25 hours. Rowan would be very strong if it was that long. Or on the moon, yes. Yeah, that's true. Yes, good thinking. Maybe it's in space. All right, difference of two squares. So that's when we have something like x squared minus y squared. Remember, we talked about this last chapter. It factors into x plus y times x minus y. But we also have something called a perfect square trinomial, which I did not make you memorize. This is when you have like x squared plus 2xy plus y squared. It factors into two sets of parentheses, x plus y and x plus y. So it's x plus y quantity squared. That's why we call it a perfect square. And then trinomial just means that there were 3 terms originally. All right, but you could also have x squared minus 2xy plus y squared. That is going to be the x minus y times x minus y. So we write it as x minus y squared. The important thing to note is that you cannot just bring the square in, right? We've talked about that countless times. It is not just x squared minus y squared. All right, so when we have problems like the next one, when we have like 36x squared minus 25 equals 0, or 4b squared equals 1, I said solve by factoring. So I'm going to get everything on one side. Okay, and I'm going to factor. So it's the difference of two squares, right? So it's 2b plus 1 times 2b minus 1. And I set each one equal to 0. So 2b plus 1 equals 0, and 2b minus 1 equals 0. So when I subtract 1, I have 2b equals -1, and then divide by 2, so I get b equals -1/2. This other one, I'm going to add the 1 over. I'm going to divide by 2, so I get b equals 1/2. Those are my two solutions. Now, some people from the very beginning would have noticed that you could divide the 4 over, and then you can take the square root, and you get b equals 1/2. But whenever you take a square root, remember, what do you have to write? Plus or minus. So you should actually have plus or minus 1/2. But those are solutions? Yeah. -1/2 and positive 1/2. So you could also do it that way. It's just a lot of people forget the plus or minus. So if it's difference of two squares, you might as well factor. All right, so this next one. So same idea. You could add the 25 and divide by 36, take the square root. But we're going to go ahead and factor. It's the difference of two squares. So I'm going to have 6x plus 5 times 6x minus 5 equals 0. So I'm going to have 6x plus 5 equals 0 and 6x minus 5 equals 0. So subtract the 5 and divide by 6. So -5, 6. Add the 5 over and divide by 6. So I get 5, 6. So -5 over 6 and positive 5 over 6. Okay, so lots of other problems like this. These are all factoring. So I always need, when I'm factoring, to set equal to 0. So I'm going to add the 4 over. I'm going to have y and y. I need -2 and -2. So for this one, I can do y minus 2 equals 0, and I can do another one. I can say y minus 2 is also equal to 0, but it's pointless, right? It's the same answer. So I'm still just getting y equals 2. So think about what the graph of this one is. If I was going to graph it at 2, that's where the vertex of your parabola is, 2, 0. Like it's one where it hits it and pops back up. There's not two answers, there's just one. right, so same idea on the next one. So I have 4x squared minus 4x plus 1. So I'm going to have 2x and 2x. I need -1 and -1. It's another one that only has one solution. So 2x minus 1 equals 0. So I get x equals 1/2. All right, the next one, so I'm going to have 10x squared. I'm going to get everything set equal to 0, so I'm going to subtract my 9x over. I'm going to add the 2 over. Then I'm going to factor. Okay, if I have 10x squared, I'm going to first try 5x and 2x, the ones that are closer together. So let's say I try 5x and 2x. I'm going to be smart, and I'm not going to put a 2 here, right? We talked about that last chapter. If we did, then we would have a GCF. Right, we can't have a GCF because we didn't have a GCF here. Okay, so that doesn't work. So I'm going to put the 2 here and the 1 here, and then I'm going to think about my outer and inner. I have 4x and I have 5x. Can those combine to be -9? Yep. Both negative, right? So set each one equal to 0. So I have 5x minus 2 equals 0. I have 2x minus 1 equals 0. So I add the 2 over and divide by 5, 2/5. Add the 1 over, so I have 2x equals 1. And divide by 2, so x equals 1/2. This section pretty easy so far. Yeah, you guys did really well on your factoring last chapter. So. All right, so next one, just make sure that you subtract it so that it's in order, right? So you want to subtract out, and you'll have 8x squared minus 2x minus 3 equals 0. So you factor. So instead of trying 8 and 1, I'm going to try 4x and 2x. I start thinking about where I'm going to put the 3. If I put the 3 here and the 1 here, it's not going to work because I'd have 12 and 2. I need them to combine to be -2. So I put the 3 here and the 2, or in the 1 here. Did I say 2 before? I don't know what I said. Okay, so I get 4 and 6. So I need -6 and positive 4. So I have equals 0. So I have 4x minus 3 equals 0, and I get 2x plus 1 equals 0. So I get 3/4, and I get -1/2. Okay. Good so far? All right, so the last thing is something that you probably did not do in Algebra 1. This is a little bit different. So it's going backwards. So it's saying, well, what if we know the x-intercepts? What if we know the zeros? How do we get the function? Okay, so it says write a quadratic function in standard form with zeros of 3 and -2. Okay, so if I'm going to have a 0 of 3 and a 0 of -2, that means when I factor it, what do I need to have in parentheses if I have 3 as a 0? I need x minus 3. Does that make sense? So going back up, let's go to number 3, like looking at number 3. See how you had y equals 2 as an answer? Well, that meant that y minus 2 was what you had in the factored form. Does that make sense? So that's what we're doing here. So we're saying if I have like 3 as an answer, I need x minus 3 in the factored form. Okay, so what if I have -2? What do I need in the factored form? X plus 2, right? Does that make sense? So I'm going to have some kind of function with those 2 sets of parentheses. All right, so when I FOIL it out, I want to see that it's actually in that form, the ax squared plus bx plus c. So I FOIL it out. So I have x times x is x squared. My outer is 2x. My inner is -3x. My last is -6. So my factored form, or my FOILed out form, is x squared minus x minus 6. That's my function. Okay, that function has 2 x-intercepts, one at 3, one at -2. Okay, but is that the only function that has those zeros? No, you can have lots of other functions that have those zeros. I could have had any number that I wanted right here, like in the front. So like I could multiply my whole thing by 2 and have 2x squared minus 2x minus 6. That would still have the same zeros, like the same solutions. You just would have a 2 out front. Do you guys see what I'm saying? So there's an infinite number of functions. It's not like the only one. Or I could have like a negative, right, where it's all downwards. Ooh, I tried to erase. Did that like wiggy out? Moved all my words. All right. Okay, so I can have any number out front. All right, so next page. So it says write a quadratic function with zeros of -4 and 1/2. So if I have a 0 of -4, that means I need x plus 4. If I have 1/2, I'm going to go ahead and write it as x minus 1/2 right now. That has a 0 of 1/2, right? See, if I plug 1/2 in, I get 0. Okay, but I don't want to FOIL that out because I'm lazy and I don't like fractions. I really do like fractions. I'm a math teacher. Come on. We didn't. I like fractions. Okay, but let's say that I don't want to multiply out with fractions. How can I make it nicer? Yeah, just multiply by 2 right here. So you're going to squeeze a 2 in the middle there. So that way, when you multiply, you have 2x minus 1. See how you like distribute it in here? Does that have a 0 of x equals 1/2? Like if I set 2x minus 1 equal to 0, do I get 1/2? Yep. Does that make sense? So it's kind of like those ones we did in the last section, like when I had 6x minus 5, it gave me 5/6. Does that make sense? Okay, so that's what we're doing. So basically, like write it like with the 0, x minus 1/2, and then multiply by whatever you need to make it nicer. Okay, so then I'm going to have x plus 4 times 2x minus 1. So that's going to be what my function is going to equal. So I'm going to multiply out. So I have x times 2x is 2x squared. My outer terms make -x. My inner terms make plus 8x. So -x plus 8x is plus 7x. And then 4 times -1 is -4. That's the function. So same idea on the next one. I want a 0 of -3/2. So I'm going to need x plus 3/2. And then a 0 of 7/3. I'm going to need x minus 7/3. But I want to avoid the fractions. So I'm going to multiply the first set of parentheses by 2 and the second set of parentheses by 3. So I clean it up a little bit. So I have 2x plus 3, and I'm multiplying by 3x minus 7. And the reason I can do that is because, like I said, there's an infinite number of quadratic functions with those zeros. I didn't say, like, write the quadratic function with the 1x squared out front, right? This is going to end up having a 6x squared, but it still has those zeros. So 6x squared minus 14x plus 9x minus 21. So it's f of x equals 6x squared minus 5x minus 21. That's your answer. All right, number 10. So write a quadratic function with zeros of -4 and 0, but now this one's going to have a leading coefficient. So what I mean by leading coefficient is the number all the way out front. So on the last one, the leading coefficient was 6. It can be anything, but in this one, we actually want to specify what it is. So leading coefficient of 3. So I always take care of that at the end. Okay, because like, for instance, on number 9, what if I said I want the quadratic function with zeros of -3/2 and 7/3 and a leading coefficient of 12? Well, what would you do at the very end of number 9 if you wanted 12 to be at the beginning? Multiply through by 2. Does that make sense? So I don't want to put like a 12 out front and then go bigger than what I really want. So I kind of do it at the very end. So I'm going to have a 0 of -4, so I need x plus 4, and a 0 of 0. That's like x minus 0, right? You're always doing like x minus the 0, x minus the 0. So in this case, it's just x. So x plus 4 times x gives you x squared plus 4x. But we want a leading coefficient of 3. So we're going to take the whole thing, and we're going to multiply by 3. So that's why I was saying I kind of just do it at the very end. So you're going to have 3x squared plus 12x. Don't forget to multiply it into the second thing as well. Multiply it in everywhere. So 3x squared plus 12x. So if you factored it, you would get solutions of -4 and 0. All right, a couple more. All right, sorry, did I go too fast? All right, so I do talk about irrational zeros as well, like things that have square roots. I forgot to put this on your homework. So bad. Doesn't mean it's not going to be on the test, though. So just because I forgot to put it on your homework doesn't mean you won't have it on the test. All right, so write a quadratic function with irrational zeros of 2 plus √3 and 2 minus √3. This is a little bit tricky. Okay, so when you have this, this means that you need, it's always in the form x minus the 0. So we're always doing x minus each of the zeros. So in our case, it's x minus, and my 0 is the whole 2 plus √3, like all together. So I'm going to put it in parentheses. So I'm going to have x minus the whole 0 is 2 minus root 3. So I'm going to distribute my negative. So I'm going to have x minus 2 minus root 3 times x minus 2 plus root 3. But it's a little bit tricky because it's not in the form that I want. I want ax squared plus bx plus c. I want to see what my coefficients are, a, b, and c. So what do I need to do? I'm going to multiply it out. You guys see what I need to do? This is what we did in chapter 5. You guys hated this. I'm going to multiply the x into all three things. And then I'm going to multiply the negative 2 into all three things. And then I'm going to multiply the negative root 3 into all three things. All right, so here we go. So x times x gives you x squared. X times negative 2 is negative 2x. X times root 3 is x root 3. Then I have the negative 2 times all three things. So I'm going to have negative 2 times x is negative 2x. Negative 2 times negative 2 is plus 4. Negative 2 times root 3 is negative 2 root 3. And then I take the negative root 3 times all three things. So I have negative, what is it, x root 3. And then I have plus 2 root 3. And then I have minus root 9, which is minus 3. Big long function. But since these were conjugates of each other, 2 plus root 3 and 2 minus root 3, you're going to have a lot of things cancel. Okay, so go through and cancel anything that's opposite. So like x root 3, negative x root 3, 2 root 3, negative 2 root 3. So you end up getting x squared minus 4x, and then I have plus 4 and a minus 3, so plus 1. That's the function that has zeros of 2 plus root 3 to 2 minus root 3. It's one of the functions, I guess. I could have it in any number up front. All right, does that make sense? It's messy, but it kind of makes sense. All right, and the very last question is kind of a typical question that would be like on a standardized test. Like on the SAT, you have something called grid-ins on the SAT, where you have to grid in a solution. So a lot of times they'll say things like, find the integer solution, find the positive solution, find the whole number solution. Like they'll say something like that on the SAT. So this one has two solutions. So 2a squared minus 8a minus 42 equals 0. It has two solutions, but only one of them is going to be positive. So do you guys see that this one has a GCF of 2? No. So pull out the 2. And then you're going to factor. So you're going to factor into a minus 7 and a plus 3. And the 2 is still out front, but it doesn't really do anything. It's saying like 2 times something equals 0. Like the 2 is not what's making it equal to 0. So you could write that. You could say 2 equals 0, a minus 7 equals 0, a plus 3 equals 0. But like 2 equals 0, that's nothing. That's not helping you. 2 is not equal to 0. But a could be 7 and a could be negative 3, and that would make it 0. So when I say something like, what is the positive solution? It's 7. So that's the answer.